So, dynamic CSS. You might recognize me from last year when I talked about design patterns. That's actually Jacob earlier this week. I also run a small agency called Oddbird. We're a full stack services, including Vue. And I built Susy. Please don't use it, ever. We're going to talk a little bit about the history of the web, starting in 1993 with the introduction of HTML. I'm not going to spend a lot of time on that. This is me in 94, doing my first client project with my brothers. We became Oddbird later. In 97, we got font and table in HTML 3.2. That's pretty cool. You may have had several people yell at you that tables are for data. They are. I don't need to yell it. In 2000, well, in 96 and then actually in 2000, we got CSS, cascading style sheets, and everything was better and we're done. So, thank you. This is actually a feature, but we're going to come back to that. In 2007, between 2007 and 2010, we started to get lots of grid frameworks. This made a lot of sense at the time, particularly because we were doing floated layouts. And there was a lot of hacking involved, not just clear fixes, but at that point, the double margin bug and various other bugs, and fixing different widths for different browsers because of the box model. There was a lot to fix. And this was sort of the first open source CSS we started to see, helping us do all those hacks as well as build layouts. And they look something like this. You get 12 columns across, you get some gutters between the columns, and you can span some of them. Great. That worked. It often had a class-based API. That's pretty much the API we get in CSS, or at least at the time, where you'd say, okay, this is a column. It's going to be 6 of 12, and this is the last one, so remove that final gutter. And that's how we built grids for quite a while. Around that time also, I saw this talk from Natalie Down. I saw it online because I don't live in London. But I liked her approach. She was saying, instead of having these big frameworks that give us the same thing every time, what if we had systems and ways of talking about building grids, and we could reuse those from one project to the next while changing the details, adjust for each client, adjust for the need of each project. And it made sense that she was coming out of an agency where she was going project to project. And that's what I was doing. So that's maybe not as necessary if you're internal to a company and you're working on the same project for 10 years. You don't need that adaptation from one to the next. But I really liked her approach. It sort of was based around this algorithm. The target divided by the context times 100% is the width of every element. So you've got the parent width as the context. You've got the number of columns you're going for as the target. You run that algorithm. And I was just doing that over and over again, and the CSS looks something like this, which is not entirely readable. You see those big numbers, percentages. I was just typing those numbers into a separate calculator, copy and paste, put them in the code. Sometimes remember to put a comment. Otherwise, it's meaningless, and nobody looking at the code has any idea how I got that number or what it means. 2009, this is around the time I was starting my company. This is not actually when Sass was first written, but it's sort of when Sass took off, and it's definitely when I heard of it. And that's what's important, really, right? And I built Susy right away because I was just doing that, that math equation over and over and over. And that's the only reason I wanted to use Sass, was to do that math for me. So I built a little tool that does that math for me. It's just some functions. And it makes things a little more readable, right? That's the goal. We're trying to get at readability. And normally here I would quote Sarah Drasner, but I didn't have time in this talk, so sorry. In 2009, we also got media queries for the first time in the browsers. Safari 4, this is sort of if-then statements in CSS. This is the first if-then statement in CSS. We now have several. But media queries are cool and led to this 2011 responsive design idea. Once there was more implementation of media queries, Ethan Marcotte suggested maybe we can use these media queries to make changes and support more browsers or devices. There's a few of them. This is just a small number of the actual devices being used. The web is diverse. There's a lot out there, and it's not just people that are diverse, but devices that are diverse, and then people with devices, and then all sorts of combinations, and it gets a little bit exponential, and you have no idea who you're shipping to. So we need this concept of CSS is that we are shipping to lots of unknowns. There's too many variables. We don't know them all. And that's what browsers are for. And that's how CSS is designed, so that browsers do certain things by default, and we send a few suggestions for how you might clean it up in the browser. And the browser looks at those suggestions and makes the necessary adjustments. We're trying to, in some ways, write as little CSS as possible and let the browser do its thing. The browser is smart, and we don't want to have to build everything from scratch the way we would with a different type of programming language. So we wanted to define a few constraints to get where we're going. What we're really trying to get at is clear relationships. We want everything on the page to be related to each other, not necessarily explicit, because then when we change one thing, we don't want to have to change everything around it. We want sort of these implicit relationships built up so that when one thing changes, everything else moves. And the first rule of the browsers is do no harm. So if you give it too many instructions, you set a height and a width, and it's got to overflow, the browser is smart and says, we're not going to harm any content here. We're going to show you everything. That's a feature, okay? Anyway, if your design tool didn't allow you to do that, you'd be pissed. So we've got a declarative syntax, and that's part of how CSS is designed, but that doesn't mean it's static. The results are anything but static. We're using this simple declarative syntax to set some constraints for unknown variables. That's where we're trying to get with CSS. So one of the first rules of that is that we're always going to try to go with the flow. And the flow is basically this. In an inline flow, things stack up left to right, or right to left if you change the language. And if something changes, everything else moves around it. They flow together. That's handy. We can toggle that flow to be block, and then things flow vertically, usually. Now you can change which direction is the block flow and which direction is the inline flow. We're not going to get into that. But flow is handy, and we want to use it. We want to use it so that when we change the size of the logo, because the client always wants the logo bigger, everything else moves and adjusts, and we don't have to move everything down to adjust for that bigger logo. In 2011, we also got calc. This is functions in CSS. Look it up. CSS is now Turing complete. But we do have calc function that's been available for quite a long time and is quite handy. It lets us put together different types of units. This is something that no preprocessor can do. Sass has no concept of how a pixel might combine with a percentage, but a browser can figure both of those out and add them together and give us a final result. So we can start combining fluid and fixed objects into the same layout at the same time using calc. That's real handy. 2012, we got Flexbox. That came along pretty quickly. And Flexbox sorts of gives us these relationships in a more clear way, ways of distributing space, ways of rearranging things. We can tell everything how to flex to take up remaining space or to use less space if there's not enough available. We can make those relationships more clear and how items should work. It still is just going in one dimension, left to right and then wrapping. It's still defined by the elements themselves, so there's still some fragility there. But it gets us part way, and it's real handy. So we can say we have an ideal width, which can be set to auto, the default width of the element, or anything else that we want. We say this is the ideal, and then we say how much am I allowed to get bigger, how much am I allowed to get smaller. That's the 1 and the 0. In 2014, we got CSS variables. Did you know that we've had them that long? It's been a while. Unless you count current color, in which case we've had them quite a bit longer. that is a variable, just not one that you set exactly directly, but that gives you the current value of the color property. So CSS variables work something like this. We've got the -- name, and then the value of it. They're also called custom properties because calling them variables was a quick way to make people understand what they are when actually they can do quite a bit more, and that functionality is coming. It was a way to sneak them in there. It's basically an empty browser prefix. So where you would do -WebKit or -Mozilla, you just do -- and that's yours. You own that one. So to call a CSS variable, and I didn't get a picture of Mike to throw in here, that's really too bad. To call a CSS variable, you use the variable function, you give it the name of the property that you've created, and then after a comma, any fallback. And that fallback can include commas of its own if you're doing like a fallback of a font stack. Any further commas will be considered part of the fallback. But you can also nest those. You can have another variable in the fallback and nest down that way. So it's a little different than Sass variables, and you'll see why. So Sass variables scope the way that JavaScript or other languages scope, where you're dealing with the file and the code itself. So if we're inside of the example and we set columns to 2, and then we go to a nested class and check for columns, it won't be defined because we're in a different scope in the code. That's because browsers don't understand Sass, and Sass doesn't understand the DOM. So there's no communication there. We can't get where we're trying to go. Thank you. CSS variables work differently. They inherit. They inherit like any other property, and that's why they're designed differently. There was a lot of talk about designing them more like Sass variables, but this is a special feature that actually opens up a lot of possibilities for us, where if we define columns to 2 inside of example, it will now be available inside of example in the DOM. The browser can understand that, and it can inherit to nested properties. Not scoped based on your code, but scoped based on the DOM. Which means where in Sass we couldn't really change the layout of something at a media query without changing all of the code produced by Sass. Here, if we changed columns to 6, it would only change in that local scope, not actually in the browser at the media query. When we do that with a CSS variable, we are actually changing that variable for that media query in the browser. So now, when the browser is above 30 ems, that changes the value of the variable. And that's super handy for dealing with layouts, particularly, but also quite a few other things. Just a few quick things about how variables work. If you set them on the root, they'll inherit everywhere. By default, they inherit. If we don't want them to inherit, we can set them everywhere back to their initial value. So that's a quick way to say this property shouldn't be inherited. We want to set it individually each time. One of the things I like using them for is avoiding nesting. So instead of saying, I have a button and then I want to change it inside of this, I can instead say, I have a button that has a variable background, and then inside of this I can just change the value of that background. I've done no nesting, but that variable is inherited, and the button color changes in that context. So this is something where you often don't want context to matter in other languages. In CSS, context is the whole point. CSS is all about adapting to context, so we want to be able to make those changes in that context without adding specificity. That also gives us safe inline styles. So I can do this button style color blue, and there's no danger that I'll want to override that later, because I can either use it and say, use whatever button is set to, or I can just ignore it, and I haven't had to override it at all. So it's totally safe to do those inline styles. And I said that like I was going to another slide. They would have something to do with it, and then I didn't. It's real rough. So another thing you can do this sort of missing longhand, where instead of resetting your box shadow the entire description every time, you can set up initially your box shadow to be built out of lots of variables, and then you can just adjust one variable at a time, and the whole box shadow will update. So it's a handy way to get longhand where you don't have it and do want it. I ended that one like I wasn't going on to something related, so I'm safe. Combining that with calc, we can start to build really complex functions where we can pass in values to CSS, manipulate them, and get a result. So we can start saying, okay, the width is going to be based on this variable I've made that is a function. It returns a value based on the span and columns, and it's just doing that same math problem that Susy was built to do, where it says, I take a span, I take columns, I do the calculation, and if that calculation comes out to something that the browser understands, it gets used in the width property, and now if I set span and columns, that element will automatically lay out based on them. So that would work something like this. I can say span 3. I can also get a little more complex with it and say, I want to span half, and I'll do a calc there that takes the result of the width and columns and divides it by 2, or figures out set span based on columns divided by 2. I can play around with those things, and it will all adjust in the browser, and the browser will do all the work for me. That also gives me smart media queries, like I mentioned earlier, where I can change the columns inside of a media query, and it will change at that breakpoint, and all of the math will suddenly change even without changing anything else in the breakpoint. That's all I need to change, and all of the math will update, which is handy. So I played with that, and I rebuilt all of Susy from scratch in CSS. I really recommend not using this, but it does give you that. You can see the columns changing there. All of that is built with pure CSS. You can play with it if you come back to the slides later. Basically, I did it again. I'm moving on to manipulating HSL values. There's just a lot to get through, you know? So we can do something similar with HS and L, manipulating them individually, compiling them together. We can start doing the theming stuff that Mike was talking about, even at another level of detail, where we're just passing in the H, the S, and the L individually. And then I can create a complement color by manipulating the hue. Hue is radial, so I can go as high or as low as I want, so it's perfectly acceptable to just add or subtract 180 degrees, and it will get us where we're going, even if we go above 360 or below 0, because it's radial and it'll just keep going around. So I can get a complementary background that way. Lightness, on the other hand, is clamped. It doesn't go below 0, it doesn't go above 100. If you do go above or below, it will just stay in the range. It will just hit 100 or 0. So you can use that to play with a contrast color. This is a pretty dumb way of doing contrast, and I mean that in the it's not figuring out much about how bright the color actually is visually. It's just looking at the lightness value, and we can create a threshold at which it will change from a white to a black text. So we can get some basics of accessibility, color ratio. We can adjust our hues here. You can see the complement changing to match. And if I move above or below the threshold, we toggle black or white text. And it's not perfect, especially with a color like yellow. Works better with a more neutral color. You can find where exactly that threshold should be. Play with that. So there's a lot we can do there, and it's not all useful in production, but some of it is. You can do things with that. Figure out things to do with that. Thanks. There's a few issues that I've run into and that I've seen from other people. Variables don't work inside of URL, which frustrates me all the time. I want to pass in an image as a variable and then put it inside of a URL function. I can't do that yet. They have unknown value types. CSS doesn't know when you create a new variable, is that a color, is that a number, is that a string? And that means that you can't manipulate them with CSS. You can't animate them or transition them. You can transition or animate what they're applied to. So you could apply a variable to background color, change the value of the variable, and animate background color. What you can't do is change the value of the variable and animate the variable itself, because CSS doesn't know how to change red to blue if it doesn't know that those are colors. You also can't do the sort of interpolation that you might expect, where you just say var size and then put an M after it. That won't give you M's on your size, but you can use a calc function to multiply your size times 1M, and that will add the units you want. It's common with CSS variables to leave units off because there's no way to remove them, but it's easy to add them. So depending on what you're doing, you might want to leave units off and then add them when you need them. Houdini is coming down the line. This is giving us lots of control over things that the browsers normally do for us. It's going to be dangerous and fun, which is what we always want. Right now it's experimental. In JavaScript, it will allow us to define properties and what their syntax is, this is a color, this is a number, and then it will be able to, CSS will be able to animate them. We'll also be able to give initial values and set whether they inherit. There's also a proposed syntax for doing it directly in CSS, which I'm very excited about, but this is not implemented anywhere. So there's some cool things coming that we don't have yet, but let's play with what we do have. I'm going to introduce Grid first before I go into some of these demos. Grid landed all on the same weekend in these three browsers. It was like I went home from work one day and I could not use Grid in production, and I came back to work on Monday and I started using Grid in production. It was that fast. Yeah, I agree. Whoa. So this is the first time that we actually get truly two-dimensional layouts in the browser. And this is really, even Flexbox was a hack for layouts. Flexbox is brilliant at doing what it does. What it does is not layout exactly. So here we have a tool in CSS that is actually designed for layouts. If anybody tells you that there's tools already that can do this or that can polyfill this, they're lying to you. It can't. Susy can't do this. You should ditch Susy. You should never use Susy again. Stop using Susy. Thank you. You get columns and rows. You get mixed units. There's a lot you can do with it. You could build this. Maria, you can build this. So mine is slightly different. I adjusted it slightly. I'm sorry. But you can see it here adapting to the size of the window that I've created for it. And we're going to look at some of that code. So all I've done is I've said this is going to display grid. And then grid template columns, I just want a 12-column grid, each one of them being one fraction of the space. Done. And then to lay something out on it, I can lay them out on the columns and on the rows. There's indexed lines. They start with a 1 index. And they also have a -1 index from the other end, both in terms of columns and rows. And if I don't want to span to a line, I can add the keyword span and say just how many lines I want to cover. And we can actually inspect that in a little bit. The other fun thing that I did here is you can do this ASCII art version of your website, which I find super handy. So I've got header across the top. So that's creating 2 columns and a row that the header is going to be that entire first row. And then I've got a second row that is the nav and the main, and a third row that has nav and footer. All in those 2 columns. You just do those, giving them any name you want, mostly any name you want. And then you can reference them there as grid areas. And that's the entirety of this layout. I can also, because I've got this single source of truth where everything is defined on the parent rather than on the children, I can change it all in one place. So to get multiple layouts here, all I need to do is add 1 media query on the parent element, change that grid template, relay out those areas in a different way, and I have both of my designs done with that breakpoint there, and that's the entirety of that code. It's so easy, we're all going to get fired. So last year, Jen Simmons started calling this Intrinsic Web Design. We got a lot of new powers. We've got fluid and fixed together, where responsive design said everything should be fluid. With intrinsic design, we can start mixing those two in much more complex ways. Why did I go forward? We've got stages of squishiness. We can have things that adjust, and I'll talk about those in a little bit. But whether we want them fixed or fluid or fixed until fluid, we've got truly two-dimensional layouts, nested contacts. We can put grids and then Flexbox and then another grid inside of the Flexbox and then floats here, and we can start combining all of these things for what they're actually built for. Content can expand and contract using fraction units and using Flexbox. And we've got media queries only when we need them, rather than as the basis for the entire layout. So this is the stages of squishiness idea. Even percentages are in some ways fixed. While they're relative to something, they don't change based on, they never change in the browser in a way. I don't know if I'm explaining that well, but we've got these fixed units where we say exactly what they're gonna be, and then we've got fluid units like fractions or like the flex adjustments that say how we're gonna take up space that's remaining or when there's not enough. We've got min-max, which gives us fixed until fluid. So we can set a minimum and a maximum, and it will be fluid between them, and that's super handy. And then auto if we want to return to the default flow, which is handy, and we can start combining all of those things. If you're not sure about these different units and how they work, here's the quick cheat sheet. Percentages are relative to the parent. Viewport units, viewport width is relative to the entire window. And fractions are relative to available leftover space, or whether that's positive or negative space. So those all work slightly differently and do something a little bit similar. Or an issue that I run into regularly, one fraction actually means min-max auto one fraction. So similar to, no, the opposite of Flexbox. This means it will never shrink, it will only grow. Which can surprise you when you throw a large image in somewhere or where you have long words. By default, one fraction will never shrink below the content size. So if you actually want something to shrink and grow, you have to go with that min-max 0 one fraction or something like it to set a minimum that is smaller than the auto. So let's add some view to this and play with it. Yeah, view looks like this if you haven't used it before. That was like my weakest call out. I'm really sorry. So I started playing with this when we had a client project that needed this day planner, and I thought, well, that's just a grid with a column for every minute of the day, and then I just need to lay things out based on where they start and their duration. So I did that, and it worked. I passed in a start time and a duration through the style, and then, through inline styles. I can, using view, I can actually just grab that data very quickly here by binding to the style tag, passing in an item start, item duration, and I set up the grid to be a minute for, or a column for every minute of the day. The tricky thing is you can only get to like 16.5 hours doing that because there's a limit to the number of columns you can have. Useful. But so if somebody goes above 16 hours in their day planner, we just zoom out to a lower resolution, a column for every 2 minutes, and it works fine. But we set that start and that duration, and you can see just a quick sample of it here. I'm passing in a layout overall, and then a start and a duration. So let's change the start to 3, and you can see I'm moving around the one that's actually first in the markup there. By default, it would start at the beginning. So you can see those values. Let's start it at 5 and have a duration of 3, or iteration of 4. So I'm getting my layout on the fly, just passing in a couple CSS variables, and I'm doing that, in this case, just by binding to view. I can also change the layout and say, what does 4 do? So 1 fraction, it's actually generating, because I have this starting at 5, it's generating automatic columns beyond my specified ones. But if I started that at 1 again and only had it lasting for 1, that would go down. We can do 1 fraction again, and now we have 2 columns, each of them 1 fraction. We could make one of those bigger. We could change it to 30M. You know, we can do anything we want here, and we're just passing in these values of the overall grid. And again, this was the question that Maria had for me earlier. How can I do these custom layouts very quickly? And this is how you can do it. But my clicker doesn't work when I'm in it. Okay, so then I was speaking at a conference, and the night before I went, I saw this artist talk. He does all this generated art using processing language. And I thought, well, that's just a bunch of grids nested in other grids. I can do that. Let's make some art with Vue. So I had to learn some JavaScript quick. I hadn't learned JavaScript before, although I didn't actually learn it. I was introduced to it because JavaScript cannot be learned. But it was a good introduction. I was able to put this together. I read a lot of Sarah Drasner's articles and then built it so I can get some more Space Invaders here, or I can take away Space Invaders. And I can change all these values. I just wanted that to be like, let's make them big. Let's change them to 1M. I can change the size of everything, play around with it. All the things you need to do. I can also shuffle them because, I mean, that's the main thing that Sarah teaches you if you start from her articles. Like, yeah, transition group. I love it. I actually have, where's this? Let's just do a quick asteroids. Yeah, oh, I'm not controlling it. I'm supposed to have control of this guy. Yeah, oh, it just destroyed everything. All right. Anyway, now we've gone out of my talk. Will we ever make it back? No one knows. Yeah, it's basically just a bunch of little dots that turn on and off. So you've already learned how to do that. And I'm just passing in those 2 sizes that I have. They're just passed in as CSS variables on the style tag. And then I've got this display grid. The grid autoflow dense is what makes them fill in the gaps, even going backwards to fill in gaps when I have smaller ones following larger ones. That's real handy. And then I've got a default size and gap there, and my grid calculation. That's because in order to get things square, I needed to know the actual size of things. Otherwise, I would let the browser figure that out. But I needed to know to be able to set the height the same as the width. The rows are being set automatically by the stuff inside. The rows are actually using that grid value. So I've got the grid value there, and then I'm auto-filling. I already destroyed them all, so I can't show you. Autofill just means you're gonna get as many columns as will fit. And then I can pass in a grid gap, which actually, if you've ever built a grid system, which I have, and I don't recommend it, gutters are the problem. Layouts are easy, even with floats, if you don't have gutters. As soon as you add gutters in, it's a problem. But if the browser does it for you, that's no problem anymore. So then for each individual item, I pass in the size of the invader, whether it's a 1-column invader or a 3-column invader. I can pass that in. And then on each invader, I take that span and add it both to the column span and the row span. And I do an internal grid that's the 5x5 grid that will be the actual design of the invader. And I pass in these blips that just have an alpha tag that turns it on or off. I can pass that into HSL again, or HSLA in this case, and turn on and off my blips to get the layout of each individual invader. And then I put them in the right place using the column, and I let them auto-flow rows, and it all comes together. So then I saw somebody wrote an article on CSS tricks about bar charts, and they didn't use variables. And I was like, how can you not use variables? Let's do that. So this is the code I started with. I think I've actually switched to tables at this point, but it's the same exact idea. I'm passing in a scale on the outer one, and then I've got the values themselves on the inner. And here it is. You can regenerate the data. We can change the scale. So if we make that scale bigger, you can see the values all adjust. That background image is also being generated using those same variables to create the repeating pattern. Oh, it doesn't like when yeah, that's fun. I can also adjust these, the background colors. It's a large background gradient that is then moved left to right based on the value that's passed in, so that I can get that. Let's actually adjust it. So if I remove the position there, they all go green. If I remove the background size, you can see the entire gradient. And then I'm just moving that gradient left or right to get the actual value I want. So there's a lot you can do passing in raw data to CSS. Oh yeah, here's the bar themselves. It's taking the start plus 1 for the one index, and then subtracting the value to get where it should start on the grid. I saw somebody at the next conference show this graph, and I was like, okay, we can do that too. This is just 3 dimensions. We can play with that. That wasn't much different, pretty much the same thing. This one I actually used clip path instead. I don't really love the way it works, but it did work. So clip path is just taking those individual values, using CSS variables again, generating a clip path based on the variables, and clipping the graph to match. And then yesterday, I did have a day. I thought, well, we can probably do animations with this, right? We can take a sprite and pass in a few values. Basically, we want the 2 attacks. We've got the normal attack and the special attack, and then we've got each sprite is around 415 pixels. So I put this data into Vue and said, let's make a component that can just take a few values and automatically figure out what sprite to build, all in CSS. CSS will do all of the logic. So we've got the sprite source, which is just the image itself, the height and width of a single sprite on the map, and then how many maps to get, or how many steps to get across the map. And then for each action that I wanted, I passed in what row it is, and it just jumps down 415 pixels for each row, and I gave it a name. And then I'm just passing these values directly into CSS, because I don't want Vue to actually do anything with them. I want all of that to happen in CSS. So CSS grabs them, it says, okay, sprite demo, we've got the height, we'll set the height and width variables, and we'll pass those down to the children. We're gonna get a grid that auto-fits them. That doesn't actually really matter for what we're doing. And then this position Y, pause Y there, is where I'm doing the actual calculation for the rows, make sure that we're on the right row for what we're trying to do, and an animation there that steps through them using the step value. So here we go. There's our normal attack, and there's our special attack, just using those CSS variables passed in. If you want to find out more about variables, I started learning them from Leah Veru. She does a lot of great talks on that. You can find one of them there. There's also some fun things that I saw Mauricio Palma do. He has all these movement demos using your phone, using the gyroscope to set variables and do different things. So those are fun to look at. If you want to learn more about grids, I highly recommend Rachel Andrews' Grid by Example. She gives you not only tutorials on how to get started with grid, but also common patterns, common grid patterns that you can copy and paste into your code, and then also fallbacks pre-built for those patterns. Seriously, you can start using Grid in production now, and you should. It's so much faster than everything else that you have so much time left over to write your fallback. Like, it's not, you're not adding extra time. Just write it in Grid and then go write the fallback. It's that handy. Jen Simmons also has Layout Land. Her stuff is amazing, and she'll tell you to start thinking like an artist again and stop doing those same layouts over and over, because it's time to start thinking bigger. There's a lot we can do with CSS. Thanks, Sarah. There's a lot we can do with CSS. We're not nearly using its potential. So go out and have, oh yeah, CSS is actually awesome. Go out and have fun. Thank you.